All right, so welcome to the video lecture series on Introduction to Computer Networks. And this is part 5 of our lecture on the Internet Protocol. We will start off from the point where we left off, and that is going to be the topic of subnetting. So, networks, as we have already seen, have specific number of network ID bits and host ID bits, and that defines how many hosts that we can have for a given network, right? So if we have 10 bits in our host ID, that would mean that we have 2 to the power 10 minus 2 number of host IP addresses for that given network. However, there is a certain problem that subnetting addresses, and that is organizations, let it be campuses or offices, they may have multiple segments within the same network, and they would like to have separate management of these smaller networks. So what subnetting does is that it allows us to divide a large network into smaller subnetworks. So the hierarchy that we see is that a large network, let's say for a university, and then we have smaller subnetworks for each department. Let's say, the engineering, the medical school, the library, etc. So we will see how we can create this subnet, and each part of the organization, what happens in the subnetting is that is allocated with a certain smaller range of the IP addresses, and this smaller range is defined as the subnet. So in this simple example, let's say the university network is 128.143.0.0/16. Then we can create multiple smaller networks where 128.143 remains the same. However, we can create multiple additional smaller subnets by keeping the network prefix to be fixed to 128.143 and then create smaller subnets. And the advantage is that each of the smaller subnets could be managed and administered individually. One of the advantages that we have is not only is what we have already mentioned, is that better management. However, an additional thing is that when we create subnetworks from a larger network into divided subnetworks, overall we can say that improves the routing efficiency. Additionally, it also enhances the security of the network, because each of these subnets could be managed separately with separate security settings, etc. And also, let's say one of these hosts would like to send out a broadcast message to all the other hosts in the accounting division. It can only use the broadcast domain of the accounting subnet. So that means that it reduces the size of the broadcast domain, and therefore overall reduces the number of packets which are propagating in the network. So for example, over here, if this host needs only to send a broadcast message to the accounting hosts, and it sends out a broadcast message, it would also be sent out to the other hosts in the marketing division. But in the case of subnetting, it is reduced to only the subnet. So the basic idea of subnetting is that we would like to split the host portion of the IP address into a subnet number. So now we have what we call a 3-layer hierarchy compared to the previous 2-layer hierarchy where we only had the network prefix and the host number. Now we keep the network prefix to be what it is in terms of the bits, but now we have a smaller segment that we borrow from the host segment and assign it to the subnet number. The remaining bits are the host number for each of the subnets that we are going to create. So the subnets can be freely assigned within the organization, given that it maintains the network prefix. And internally, the subnets are treated as separate networks. So your router can be shown as if the subnets are individual networks. However, from a larger perspective, all of these subnets will belong to the same larger network. The subnet structure, however, is not visible from outside of the organization. So any external entity will only see the network ID part and consider all the subnets to be a part of one single body. It reduces the router complexity because now the router would only need to route packets to individual subnets, and also the external routers do not need to know about the internal subnetting, and the complexity of the routing tables of the external routers is greatly reduced because everything is handled as one single large network from the outside, but inside we have multiple smaller networks. So let's see how this process would work, the specific method. We would like to first borrow bits from the host ID segment. We keep the network ID segment to be the same. The number of bits that we borrow from the host ID for the subnet defines how many subnets that we can create. So if you're borrowing X number of bits, 2 to the power X is going to be the number of subnets that we can create. And very similar to what we have already seen before, for every network we have 2 addresses where if all the bits in the host ID part is set to 0, it is the network, and where all the host ID bits are set to 1, it is the broadcast address. However, here, given that we are dealing with subnets, we now refer to it as the subnet address, where all the bits in the host ID is set to 1, and the subnet broadcast address, where all the bits in the host ID part is set to 1s in the broadcast and set to 0s in the subnet address. So therefore, the total number of hosts that we can allocate for every subnet is now going to be 2 to the power y minus 2, where y is the number of bits that is left in the host ID segment. And the number of bits that we borrow from the host ID to generate the network, for generating the subnet IDs, defines how many subnets that we can create. So therefore, if we are borrowing 2 bits, we have a total of 4 combinations: 00, 01, 10, and 11. And all of these could be different subnets. Let's say if we have 3 bits borrowed, that would mean that we can have 000, then 001, 010, 011, then 100, 101, 110, and 111. Right. So as you can see that the number of bits that we borrow from the host ID part for creating the subnets allows us to create multiple different smaller networks, and we leave the same bits for the network ID segment, but just create multiple subnets for the remaining bits. So let's look at an example here. So let's say we have a network address which looks like this, 192.168.00/24. This means that a total of 24 bits is allocated for the network ID. So that is something that we cannot change. And if we convert it to the equivalent decimal, equivalent binary, the first 3 octets cannot be changed for any of the bits. The net mask, the network mask for this network is 255, 255, 255, and 0, which means that all of these are 1s, and then the remaining host bits are set to 0s. Right? So for this, we say that there are a total of 2 to the power 8 minus 2, that is 254 hosts in this one single network. So now let's say we would like to create 2 subnets for this IP address. So for 2 subnets, we know that 2 to the power x is the number of subnets. So if we set x to 1, then we can create 2 subnets, right? So we only need to borrow 1 bit from the host ID part. So before we had 8 bits left for the host ID, now we have only 7 bits set for the host ID. So 2 to the power y minus 2, where y equals 7, gives us 126 hosts in each subnet. Right? So if we have our original network address to be like this, where this was our first 3 octets, and this is the network ID part, and the last octet to be host ID, if we would like to create 2 subnets, we leave the network ID part to be the same, but now we can borrow 1 bit and flip it between 0 and 1 for the 2 subnets. The remaining part, which is the remaining 7 bits at the extreme right, is the host ID part now. So therefore, our subnet address, if we calculate the decimal value for this whole number in binary, converts to 192.168.0.0/25. And 25 is here because before we had 24, and now we are borrowing 1 additional bit. So therefore, for this subnet, this is a 25/25 network that we have just created. For the next subnet, which is set to 1 in the borrowed bit, it converts to 192.168.0.198. And again, this is a /25 subnet. Right? And given that we have now the 2 subnets created, we just deal it as if these are 2 individual networks. And just the same way that we calculated the host IPs, we would set the last bit from the right to be 1 for the first IP address, which is 192.168.0.1, and all the bits to 1s, but except for the last bit, which would mean that it is 192.168.0.126 to be the last IP address. And in a very similar fashion, where we calculated the network address and the broadcast address, we set all the host bits to 0s for the network address. So this is our subnet address now. And if we set all the bits to 1s in the host ID part, that is going to be our broadcast. For the other subnet, which is 192.168.0.128, if we set all the bits to zeros in the host ID, that is our network ID. And if we set all the bits to ones in the host ID, that is the broadcast, which is 192.168.0.255. And in this part, if we set this last bit to 1, that would give us our first IP address, 192.168.0.129, and we set all of these to ones except for the last bit. That would give us the last IP address, which is 192.168.0.254. So now we have essentially created two smaller networks from one large network. In the larger network, we had 254 hosts altogether as a part of one single network, but now we have a total of 126 hosts in each of these subnets, right? And before, our net mask was derived from a /24 network address, and therefore it was 255, 255, 255, and 0. But now this is a /25 address. So therefore we have to set the first 25 bits to ones and the remaining bits to zeros to calculate what we call the subnet mask. So given that this is a subnet, we now have a mask that is for this subnet, and this translates to 255, 255, 255.128. And this applies to both of these subnets. So we will look at our second example, which is going to be where we create 4 subnets from a given network. So let's say we are given a network address which looks like this, 192.168.0.0/24. So this is a /24 network, which means that the first 3 octets belong to the network ID, and the remaining 1 octet belongs to the host ID part. So that is how we look at this IP address here. And therefore, we can say that given that there are only 8 bits for the hosts, there are a total of 2 to the power 8 minus 2. That is equal to 254 hosts for this network. And what we are going to do is with that we are going to create 4 subnets for the above network. So now we know that it is 2 to the power x, where x is the number of bits that we need to borrow for creating the subnets, and if we set x equals 2, 2 to the power x is equals 4. So that is the same number of subnets that we would like to create. So therefore, we only need to borrow 2 bits from the host ID segment. So before we had 8 bits for the host ID, now we have 6, and therefore 2 to the power 6 minus 2 is equals 62, which means that for each of the 4 subnets, we now have 62 hosts in each subnet. So if we convert the network address in binary, this is what we get for the network address part, where the first 3 octets belong to the network ID and the last octet belongs to the host ID, the last 8 bits. And we have seen that we need to borrow 2 bits from the host ID part to create the 4 subnets. So therefore, we leave the network ID part to be the same, and we borrow 2 bits for creating the subnets. And that gives us the combination 00, 01, 10, and 11 for the 4 subnets, and the remaining 6 bits to be the range of the host ID. So now if we look at this first subnet, and if we convert this whole binary IP address, it comes down to 192.168.0. And given that we borrowed 2 bits from the host ID, now we have a total of 26 bits which belong to the network part, the network and the subnet together. So this is now a /26 network. Similarly, for the second subnet, if we convert this whole binary number into 4 octets, we get the decimal of 192.168.0.64/64. For the third, the IP address converts to 192.168.0.128/26. And for the fourth and final one, we have 192.168.0.192/26. And just the way that we calculated for individual networks, that's the same rule that we apply for subnets. We just take this subnet address and we set all the host bits to zeros. We get the subnet address. We set all the host bits to ones. We get our broadcast address. And then if we set 1 to the last bit from the right, that gives us our first usable host IP address, which is going to be 192.168.0.1. And then we set all the bits in the host ID part to ones except for the last one on the right. And if we convert it, that comes down to 192.168.0.62. And this is going to be the last usable IP address. And similarly, if we calculate for the second, the third, and the fourth subnets, we get the network address by setting all the host bits to 0. We get the broadcast address by setting all the host bits to ones. And if we set the rightmost bit to 1, we get the first IP address. And if we set all the host bits to ones except the right, we get the last IP address. And that is how we calculate for each of these subnets and the range of IP addresses that you can use for each of the subnets. And as you can see here, having one large network is great, but then if we have 4 smaller networks, we now have a better control of each of these smaller sized networks. So without subnetting, all of these hosts, if we have a network, let's say 128.143.70.0/16, this means that the subnet is going to be 255.255.0.0 for all of these hosts for this network, and all the hosts are assigned IP addresses from the same range, which are all /16 IP addresses. All right. However, what we have seen before, that without subnetting, all the hosts are part of the same network, even though they have different kind of IP addresses here. So the first 2, if you see, starts with 128.143, which is our network ID, and then the first 2 are 137, and the second 2 are 71. So if we try to kind of efficiently create a subnet for this setup, we can say that we can create 2 subnets for the same IP address for the network. So for example, here we have 128.143.0.0/16, and we can create two subnets where one subnet is 128.143.137.0 and the one is 128.143.71.0, and we are borrowing 8 bits together to create these two subnets. So it's not necessary that you are limited to only 1, 2, or 3 bits. You can borrow any number of bits from the host ID part to create your subnets. It just means that you are left with lesser IP addresses for the hosts, and the more number of bits that you borrow from the host for the subnet implies that you are able to create more number of subnets if it's necessary. And in this particular example, these two hosts would go into this particular subnet, and these two on the right will go into this particular subnet. And just for the fact that our subnets now have a /24 address, our subnet mask also changes to 255.255.255.0, which means that the first 24 bits are set to 1 and the last octet is set to 0. And also, all the IP addresses are now /24 IP addresses.